what makes a bee good in breeding queens. And that brought me to Worrel here. Worrel is a Ph.D. student in with FAMU, where I'm on staff at, and the University of Florida. They have a hybrid program, and he's a lifelong beekeeper. He comes from Jamaica, and I lean heavily on Worrel's knowledge. I think he's absolutely spectacular. He's got a lot of insight. He's very knowledgeable and very wise with bees, and consistently amazes me. So here in a little bit, I'm going to turn this over to him. But one of the major questions that I often hear from people is, why are the honeybees dying? Why are they declining? Why, what happened? And there's rumors that it's because humans are encroaching upon their wild habitats, if you will, or we're killing them off with pesticides, or things of this nature. And there's some truth to that, but that's not their main challenge. That's not their main challenge. I think that they have really three main challenges, the honeybee does. And one is a misinformation or a lack of understanding by us, by human beings, as to what these creatures bring to the table. I guess we could say pun intended on that. That would be one major challenge. Even myself, many years ago, it haunts me, but many years ago, I had a swarm, and we'll talk about swarming here in a little bit, but I had a swarm come and take residence up underneath my hurricane shutters 1 year after a hurricane. And I didn't really understand them that much, so you know what I did? I killed them. And that's shame on me. Because if I really understood, maybe I wouldn't have done that. As a matter of fact, I know I wouldn't have done that. So the other two issues that they have that are probably more impactful from a position of decline of the species is two creatures. Both of them are non-native. One came from Africa, the small hive beetle. That one's not as bad. The really, really bad one that we have is the Varroa Mite, which came over here from Asia. And both of these pests popped up in the United States back in the 80s and took root. Now I know up north, where it gets really cold, the small hive beetle is not a big ordeal. Some people that I know up in, for say, Wisconsin, have told me they've never seen a small hive beetle. But down here, any of us that are, beekeepers, we wrestle with these little guys all the time, and it's just a fact of life. But it's the Varroa Mite that really, really, really injures them. And I'm going to let Worrel give you a discussion on those guys. But looking at the honeybee itself, this is a very benign insect. Okay, now some of you have heard about the Africanized honeybee. Put it out of your mind. Okay, those are so few and far between. And Worrel may correct me on this, but we have a really good management process here in Florida to make sure that strain of honeybee doesn't get a root. So anytime we go out, we capture a feral swarm. Somebody says, "Hey, I got a swarm," right? We requeen it, which means that we kill the queen, and then we give a domesticated queen the opportunity to take over that colony, which removes a lot of that aggression. So just a few things on honeybees. By far and large, the honeybee is a very gentle creature. It's not uncommon for me to open up a hive and just go inside there and start to work that hive and never get stung. Not always, but it's not uncommon. They react to perceived environmental stressors more so than they do, oh, here comes a human, let's go sting that person, right? If they feel that the colony is being threatened in some way, if they feel that somebody's trying to take their food, the honey, things along these natures might trigger a pheromone, and that pheromone is an invisible scent. We can't smell it, but they can. That says, hey, there's something out here, And so the bees will come out, and at that point in time, they're like, okay, let's sting. So what generally causes stings from honeybees? Maybe somebody using a weed whacker because it's got a high pitch whine. Maybe somebody not realizing that, when they open up a box, like, you go out in your front yard, for those of you that live on city water, and you got that little box. I don't know what it's called, but open it up. There's a bee colony in there. You stick your hand in there, you're probably going to get stung. But by far and large, they're a very gentle species, responsible for, I believe it's right about $20 billion in global economy. Everything that you eat, you bring it into your house. If you eat it or drink it, you can thank a honeybee at some point in time because of the nature of the pollination that honeybees do. They're incredibly important to the ecosystem. They're incredibly important to us. And I believe that for that very reason there, it becomes incumbent upon us to at least step back and try to understand what the honeybee is doing, where the honeybee came from, and really what its purpose is. And if we understand them, we live with them. I live with them. I live with probably 100,000 of them in the backyard. Between Worrel and I, we have a lot of colonies in different areas, around the area here, and they're just a wonderful, beneficial insect. So I wanted to talk just a tad bit more about understanding what a honeybee is and what's driving that honeybee. So I always like to talk about behavior. And if you've been in any of my previous conversations, you'll recognize me by saying that every behavior fulfills some form of purpose. That goes for us as humans, dogs, cats, and even the honeybee. So the honeybee's main purpose that we see, that you see, is to collect food for its colony, right? In order for the colony to live and replicate. So what happens is the honeybees that you see flying around are end-of-life honeybees, okay? These are old females who have gone through a progression or different life stages inside of the hive, have come to that point where it's time to go out and get food or forage, collect that food and come back in. This is an expendable bee. This is what you guys are seeing. The real work is going on back in the colony, wherever that colony is. So the honeybees that you see out on the flowers are collecting food, which is either nectar or pollen, and taking it back to the colony. So that way the queen can lay eggs, or they can make wax, or they're preparing for winter, or they're even going to replicate the colony. And so when I say the colony replicates, this is what I mean. Every spring, there's an instinctive nature for the colony to split. And so within the colony, there's literally tens of thousands of honeybees in different life stages, whether they're grubs, whether they're young nurse bees, whether they're guards, the queen's attendants, all the way up through to foragers. At some point in time, the queen says, I gotta leave, right? The hive, or the structure in which it lives in, has gotten so congested that she's going to take roughly half of whatever's in there, as far as food supplies, maybe young bees, workers, the whole 9 yards, and she leaves. And this is a swarm, folks. When you're sitting out and drinking sweet tea and you spill it, and then suddenly there's 8 or 10 bees all surround. That's not a swarm. They're just there to collect the sugar and take it back to the hive. A swarm is when the queen will leave and she flies to a new location. And there's a whole process to this, right? Bees go out, they scout, they look for an appropriate spot. They come back, they tell the other bees about it. More go out and check it. Then they come back, and then there's moving day, and she comes out. It's like a little black cloud. Right? If you've ever had the privilege of standing underneath of one, it actually will darken the sun. And they go to wherever this new place is. Sometimes they'll rest on an area, a tree branch, under your shed, in the hood of your car. At this point, the colony is vulnerable. The colony knows this. And this is probably the time that the honeybees are the most gentle and docile. You could stick your hand in there. I don't recommend you doing it, but you could probably stick your hand in there and lift out a handful of bees and not be stung, right? There's nothing for them to defend. And so if you see something like this, the point of me saying this is, please don't destroy that. Please, they're going to go somewhere else. And they're going to create a new home in a new hive, maybe a hollow in a tree, maybe underneath your shed. If they do in fact make a home somewhere in your property, you don't want them there. There are a ton of beekeepers that will actually come out and get your bees from you. Locally here, if you live in the Tallahassee area, we have a beekeeping association called the Apalachee Beekeepers Association, or the ABA. You can find them online really easy. There's 2 individuals there that I know that are very responsive to going and getting swarms. We got, let's see, Ryan McKibben and Josh Ray. Pretty much Johnny on the spot. They'll come and collect it from you and take that colony away. And if I'm not mistaken, I don't think anybody charges, but that's not my area. Somebody calls me and says, "Hey, I got bees." I call one of those 2 guys and they take care of it. So please don't destroy those. Please don't injure those. We'll come and get them. Somebody will come and get them. If you got a problem with them, email me. Before I turn this over and to Worrel, so cue up, Worrel. I'm about ready to give it to you. There's something I wanted to say is that I have a website. Lacey, can I give my website on here if anybody has any bee questions?
Of course, please.
Okay. It's docwildsbees.com. So www.doc, D-O-C, wild, plural, right? wildsbees.com. And if you have any questions about bees, you can get a hold of me through the website. There's docwildsbees@gmail.com is a direct way to get through to me. My cell phone is listed on the website. I'd be more than happy to help anybody with anything in regards to bees, or at least connect you with the person that might be able to do so. So with that, though, I want to turn it over to Worrel. He's spectacular. So Worrel, it's your show.
Okay, thank you very much, Dr. Lee. Thank you, Lacey, for having me this evening. Okay, we're gonna talk a little about honeybee. But before we talk about honeybee, I would like to just talk about the difference between a bees, a fly, and a wasp. So some flies will mimic the bee. Some fly will actually look like bee. They are very similar. All right, so wasps normally have 4 wings like bees, and they are relatively earless, and they have a long antenna. And they have this thin waist, and they have spores on the legs, and rough. And their skin, they have rough pit. That means their skin is kind of rough, and they have bright coloration. And this bright coloration signifies that they are chemically defended. That means they will sting. So flies, on the other hand, now they have 2 functional wings. That's why they are called diphtheria. It means 2. And they have a large bulging eyes, and they have short antenna, and they are relatively earless. So bees, on the other hand, would have 4 wings instead of 2, and not bulging eyes, and long antenna. So they use their antenna to search for food. So bees are more robust, have a more robust body. They are stocky, unlike wasp. They are more area, and these ears on the body normally help collect pollen. This normally makes them a good creature for pollination. and the legs have fewer spores. Bees normally are less pitted. That means their body more smooth, right? Both can have bright colors because bees also will sting. Most honeybees are normally black and orange and with a shiny abdomen, and not as airy as the bumblebee. So you have the bumblebee and you have the carpenter bee, which sometimes persons normally mix up. But today we'll tell you the difference between both. And so there are over 320 species of bees found in Florida. And most of them, they are solitary, and they live in the wild, and their contribution towards pollination is very, very much important. So now we're gonna go over a little and talk about honeybee. So honeybee is from the genus Apis, and they produce and store honey. And there are at least 7 species and 44 subspecies of honeybee. And they normally nest in open cavity. So the main one that we normally see and most persons domesticate and used is the Apis mellifera. And there are several races and hybrids of this Apis mellifera. Most of them are commonly managed bee in the world, and they are native to Europe and Asia. So honeybee is not native to the United States. They were brought in here. So they were brought in the Western world like in the 15th centuries. So they bred them for high honey production, gentleness, and other behavior. So normally you have 3 different types of beekeepers. You have hobbyists, you have sideliner, and you have commercial beekeepers. So the hobbyists normally 1 to 19 colonies, and they're generally interested in hive products like honey, pollen, wax, propolis, and so forth. And then you will have the second category, which is a sideliner. And the sideliner have normally 20 to 199 colonies. And these persons, they would rear bees for additional income through pollination, etc. And then you have the commercial bee farmer. Now, these are the big guys, and it's normally from 200 colonies up. And they normally do pollination service, and they generally, that's a general source of income. So they'll go to like places like California where they have almond and other crops, and they will provide a pollination service for money. So before a person go into beekeeping, there are some things that you would like to do and like to know before you start, right? So some things you'd like to know. It's very important to know bee spacing. Bee spacing is normally 3/8 of an inch. And why it is important to know bee spacing as a bee farmer. Knowing bee spacing, it will helps you to organize your colony in a way where you have less, where the bees are more efficient, and you'll find less barcombs. Barcombs are loose combs in hives, and these are made in spaces that are too wide, greater than 3/8 of an inch. Right? So a little history and beekeeping equipment is the modern design of the hives is the Longstrot hives, and the Longstrot was developed by Reverend L.L. Longstrot in the 18th centuries. So before that, they used to have persons rear bees into like hollow section of a tree, or some boxes that you'd design without bottom and you turn them down. But Reverend Longstrong in the 18th centuries find a way how to make bee boxes and design them in a way where beekeeping can be, where the bees can be more efficient and beekeeping can be more profitable. As I go along, if there's any question, you can just shout out and I'll answer. So what Reverend Longstrong designed are these boxes that can hold 10 frames. And frames are some square, rectangular shape objects that you place inside the box, and the bees would make their comb parallel on these frames. And it enables a bee farmer, a beekeeper, to monitor their hives properly and easier by just removing these frames and inspect. Before Reverend Longstrong designed these equipment, these boxes, hive body, persons usually have to use a knife or a hive tool, and they'd have to cut and remove like the comb, and once you cut and remove, that basically is destroyed. So Reverend Longstrong designed these where you put them in, you can inspect, put them back in, even when you're harvesting honey. They are very efficient. The bees don't have to start back from scratch to design these cells, these combs. So there are 3 types of hive bodies. You have the deep, which normally sits at the bottom of the colony, and that deep normally where you'd call the brood chamber. And this is called the brood chamber because you'll find the baby bees there, the queen plus a lot of brood, seal brood, open brood, and you'll find eggs and larvae. All of these you'll find down in the lowermost bottom of the hive, which is called the brood chamber. And as you go up, then you'll find more storage. So on the top of the box, you'd call it like the super, some persons call it the Illinois. But normally it's where the storage would take place. So the box, the components of the box would be like the bottom board, and you'd have the foundation and the removable frames and some type of cover. You can have a cover where it sits right over the box, where you call it the telescopic cover. And you can have a cover, it is the migratory cover. It's like just a piece of board lying on top of the hive. And this is to facilitate movement of the colonies in terms of when you're going to do pollination. So the migratory will take up less space, right? So there are 3 depth height of supers. You have the shallow, you have the medium, and you have the deep. So the shallow is like the one that persons would normally use to pack their set to allow the bees to pack their honey. And then the medium are the Illinois. They call it the Illinois. It's also a shallow, but it's not. It's more wider than the medium is more. You know, it have a deeper frame than the shallow, and the deep. Some persons call it the deep super. Also, that is the one I refer to as the brood chamber. That's a deep box. So supers may be called what they contain. So if you have brood in even if you have a shallow and you put brood in it, you normally would call it the brood chamber, even though it's technically it's a super. So what it's contained, that's normally what you call it. So brood, so you have the super brood. So the hive is made from, we normally use some form of wood that is available to you. Some persons will use expensive lumber, some persons will use cheap lumber, but it all depends on if you paint it and how you care for those material, it can last you for a long time. Some persons even use styrofoam as their boxes, and some persons use plastic. So it all depends on what you can afford and what is most available for you. But most persons would use wood as their hive bodies. And so you have the migratory, right? And bottom board. And the bottom board is the section where the hive body would sit on, and this facilitate movements of the bees to go and forage and back. It have an entrance, and the bees can go out to and fro to forage and back in. So there are different types of bottom board. There are standard bottom board, which is a solid wood with a groove around where the box can sit. And there's also another type of bottom board that is called a screen bottom board. And this one have mesh. And this have a fine mesh. The bees won't be able to fall through, but the Varroa Mite, which I'll go on to later on, which is a pest of the honeybee, will fall through these screen bottom board. Example, if you put on this screen bottom board like during the summer, warm-up period, and you use certain treatment, for example, the oxalic acid and so forth, when the mites fall from the bee, they will fall straight through this mesh bottom board and fall on the ground, fall outside of the hive. Another thing persons use is a queen excluder. And the queen excluder is to block the queen in the brood chamber. So if you're a beekeeper and you want pure honey in your super, that is your top box, you can ensure that the queen is down in the bottom, the lower brood chamber, and you can put an excluder. It's a mesh. It's a mesh, and it's used to isolate the queen and keep her in the brood area, and it prevent her from going up and laying. So there are 3 types of queen excluder. You have a metal bound excluder, you have a wood bound, and you have a plastic excluder. Any of these, anyone that is most available or cheaper to you can be used for preventing the queen. So normally on the frames, persons can either use wire, run wire across, or you can use a plastic foundation on the frame. And this plastic foundation would have impressions of the color, the comb. So the comb would have cells, and these plastic foundation would also have the imprint of the cells on it. So the bees, it's like giving the bees a start to build their combs. So some types of, some different section of the frame would the wedge top bar and the groove top bar. These are 2 different type of bars that depends on what frames you have access to. You will see the wedge or the groove, and they can be used to put the they're designed to facilitate the foundation inside the frame. And I would like to go a little bit more on the pests of the honeybee. All right, so we are losing honeybee in United States and the world. Example, excuse. And some speculations are pesticide use, land use change. Other speculations are like monocropping. There are a lot of speculation. But as a bee farmer, if you're going to start a colony, site selection is very, 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 very important. So a good apiary, what are some things a good apiary site should have? So you know bees are small and they fly a lot, and especially if they have to fly against wind current, that can be a problem. So your apiary site must have a wind barrier. If it's a windy area, it must have a windbreak or a wind barrier. It must be easy to maintain. That is, you can cut the grass, you can keep it free of ants, you can keep it free of other pests like roach and so forth. And if it's an area such as in some part of Florida where you have bears, you have to have a bear fence is necessary. And as you know, a lot of persons believe that bear rob the hive because of honey, but basically bear rob the hive because of the brood. So bear eat the brood to get that high protein. So, and if you have your apiary and it's a nuisance to your neighbors, that can also be another problem. It should not be close to pen animals. It should not contain a lot of junk equipment and so forth and debris. It should not be some person would set the apiary beside a site with some stock of junk woods or junk anything like that, because those are areas that can have high numbers of pests like carpenter ants and other kind of roaches and so forth, and those can invade your hive. And it must have plenty of food, plenty of plants where the bees can go out and forage. So if you want to maintain a healthy apiary, these are some of the things that you need to have. You need to consider when you are selecting your apiary. The next thing, after selecting your site, then you're gonna acquire your bees. And when you're acquiring your bees, from the get-go, you have to ensure that those bees are pest-free. So if you're gonna acquire packaged bees, it's best to treat your bees before you put them in standard hives. As I tell you before, the hives, the condition of a standard hive, those boxes. Or if you're gonna get them in nuke, and nukes are like, it's a mini hive. So standard hive would have 10 frames, and nuke would have 5 frames. So it's like half the size of a standard. And if you're gonna acquire bees by nuke, you're gonna have to also ensure that you treat those bees before you put them in standard boxes and introduce them to your apiary. So you're gonna find suppliers, and you're gonna ensure that these suppliers they have clean bees, and you can contact some bees club, or you can contact other persons in the area. Dr. Lee and I, we supply a lot of bees to farmers from time to time. So you can also contact persons such as us. And most persons always recommend that to start with, as a new beekeeper, it's best to start out with at least 2 or 3 colonies. 2 or 3 colonies and then you can grow with your apiary. Because some persons put a lot of money into beekeeping, and they have this passion for it, and they put a lot of money in it, but their approach was wrong, and then they end up get discouraged and don't like it. And some of that help contribute to the decline in the bee population worldwide. Persons approach beekeeping with a different mentality. So it's best to start small and grow as you go along. And normally, if you're gonna start with your bees, it's best to acquire your package bee or your nuke early in the year, like March, April, and then you can you can start from there, and you'll catch the flowering season. And from time to time, persons will have their apiary and they will normally requeen. So that's the next thing again. So the queen can be, you can acquire a queen from many different sources. And some persons acquire the queen from maybe persons who have Italian strain, or Russian strain, or Minnesota hygiene strain, or New World strain. And why some people are choosy in terms of what queen they acquire to requeen their hives is simply because some persons are in beekeeping for honey production. Some persons are in it for pollination. And some queens will ensure that their colony have maybe close to 100,000 workers all the time. They are very prolific. They lay a lot. And sometimes those queens have that good character about them, but they are not necessarily good honey producers. While some other strain, they will maintain a low population, but the honey production is so high. Some other bees like the Minnesota hygienic queen strain. So those strain, they will, some persons say they will keep the hive free from pests, like the Varroa Mite and so forth. Those bees, they have hygienic properties. They can detect a mite inside of a seal cap brood, and those bees will cut it open, remove it, and remove those mites. And they also practice grooming. They clean each other, clean the mite from each other. But that strain is good, but the disadvantage with that strain is that over a period of time, that those bees, that queen will lay her eggs, and then those and if another queen should develop from those eggs, when after that queen emerge and mate, they will mate with some other drone and they will breed, and that quality will breed out. So it's a case where you always have to go back and get the queen from that same strain, like the Minnesota hygienic. So it's unstable. So it's an unstable trait. Over a period of time, it will lose that trait. All right. Dr. Lee, you have anything you want to add? Am I good with the time?
There we go.
Yeah.
No, you're good. I have some visuals for y'all, and I apologize that we didn't have these earlier. Here, share screen. That's what I was looking for.
Okay.
Lacey, can you allow me to share a screen? It says host disabled participant screen sharing.
Oh, I'm sorry. Oh, am I sharing mine? Yeah, I'm sharing mine now. Let me.
Okay, yep, there's yours. And let's leave it right there for a moment. What Worrel was talking to you guys about, this is the typical Langstroth hive, okay? And so we have a variety of different components. Now, I know you guys can't see my mouse here, but the very bottom is a stand, and you'll see right above it is the bottom board, and that angled strip right above it, yeah, right there, that's a landing board. So when the bees come in, and the funny thing about bees are they're clumsy, they are, and they'll fly in, and if you ever have an opportunity to film bees and watch them in slow motion, it's the most hysterical thing in the world. They look like a whole bunch of drunk drivers trying to make a landing at one time. They'll hit the board and they'll crawl up in. Now above it are two boxes, and these are the deep boxes, okay? And the only difference in all of these boxes is its depth this way, okay? So the length is the same, all right, but they're just a little bit deeper. And as we go up then, all right, so these two, here I am pointing at them like y'all can see me. These two bottom boxes is where the queen does her magic, okay? And so we try to keep this area as open for her to lay her eggs. She'll lay up to 2,000 eggs a day, right? So that translates to roughly 2,000 bees being born a day. We don't want her to go higher. So as we move up that little thin board there, that's the excluder. An excluder has holes that are just the right size for the workers to go through, so they can go up and they can come down. But the queen can't. The queen's a little bit longer. She's a little bit fatter than the ordinary bee. All right, and everything above that is honey storage, and that's what a lot of people are after. You know, today I helped a lady, Worrel and I did. We helped one of our customers extract, you know, one super, and Lacey, on the right side there, those two boxes by themselves, right there. Those are the supers. They're short, but boy, when those are loaded with honey, that thing weighs 100 pounds, if not more. You know, and you put two supers together and you get it deep. So you try to pick something up that weighs 200 pounds. I don't know about y'all, but I'm getting older. I don't like to pick anything up that weighs that much. So that's why they're shorter like that, so that they don't have as much in them. Okay, and then we got the rest as you go up. But here I'm going to try to catch everybody up a little bit. I'm going to jump in here and try to share a screen now.
Okay, let me.
Whoops. What happened here? Did I hit? Okay, let's try this. Nope, I'm still disabled.
There. Try now.
Oh boy, I got a whole bunch of things. Let me close some of this stuff out.
You should be able to now, Lee.
Okay. And okay, so y'all are capable of seeing this now. Is there something up on there? It shows Florida's
A swarm.
BBs.
Yeah.
The swarm still on there?
No.
No.
Okay. Well, no. Okay, you should see something that has a couple bees on it. Identifying Florida's bees?
Yes.
I can't see. Okay.
Your first page.
Okay. So, yeah, and this is kind of where Worrel was going as we were going through this. And so what we were talking about was the differences in different types of insects. And here are some things that are confused sometimes with honeybees. Notice the thorax right here is very small, not small, but monstrous eyes. Okay, so flies and wasps. I'll get people call me and say, hey, we got honeybees, and they're not honeybees. They're yellow jackets. Yellow jackets aren't something that we want to look at. You know, here's another fly that kind of looks like a bee, right? But as we go through here, what I wanted to get to was the pests. And what you're seeing here, you guys, you see a honeybee with a red thing on it, right?
Yeah.
Okay. This is what kills the honeybees, folks. All throughout the world now, we have this little pest, okay? And this is called a Varroa Mite. Its actual name is Varroa Destructor, and that's fitting, isn't it? And these guys move with lightning speed. It amazes me when I actually see them move. But what Worrel was talking about, inside of a colony, there are 3 castes of bees, okay? You have a queen, and she's in a caste all by herself. You have drones, which are the males. And in a honeybee colony, drones serve one purpose, to mate. That's it. Otherwise, all they do is eat and take up space. And these guys, these Varroas, love the drones. And drones can go from one colony to another. A worker bee can't really do that, all right? The guards will kick them out. But this little mite will jump from bee to bee to bee to bee. And when the queen lays her eggs and a new bee starts to develop, right, for lack of a better word, they look like little grub worms. At some point in time, the worker's going to come over and they're going to cap off that cell that grub worm is in. and it goes through its change now. It turns from a larva into a bee, right? It pupates, and these mites will get in there before that cell is capped over for the magic to happen, and they'll replicate underneath there. So a honeybee goes in as an egg and comes out, has 3 or 4 of these things attached to it, and on it goes. And what they do is they suck down the fat stores of the bees. That's what they're after, but they're a vector. And a vector is something that transmits diseases. And these transmit all sorts of diseases to the honeybees. And so we'll see honeybee paralysis where they can't move. We'll see deformed wing. It's a virus where the honeybee can't fly. We see all sorts of things that these little Varroa mites inject into the colony. And in fact, they will absolutely wipe the colony out. Left untreated, this little itty bitty speck on this honeybee destroys the entire colony. Here's a small hive beetle, and you'll notice it's very, very small. These guys, they're a pest. They're not necessarily a vector like the small or the Varroa mite is. But these guys will go in, and in a weak colony, they'll lay their eggs turn to larvae, and the larvae look just like maggots. And if y'all know what maggots look like, you open up a hive and you look in, and it looks like it's teeming with maggots. That's the small hive beetle. And that's where its issues come into play. And they'll take a perfectly good colony, or what appears to be a perfectly good hive, and they'll absolutely turn it into a rancid pool of garbage seemingly overnight. The other thing we talked about were swarms, and these are the very gentle swarms that we tend to see. And you'll notice in this one, you just got some bees that appear to be hanging on a branch. And this is what a true natured swarm is. This could be the destination. I doubt it. But this could be the destination that they're headed for and create an open air hive, one that's exposed. As Worrel said earlier, though, honeybees like to form their colonies in cavities. So what you might be seeing in this particular picture is the honeybees just taking a break, okay, for lack of better words, and then they'll move to the next leg of their journey, which is into that cavity being maybe an oak tree hole, right? Maybe a stump, or like I was saying earlier, underneath your carport, in your garage, in your basement, in the walls of your house, okay? They're very industrious, and they only need, Worrel is talking about bee space, 3/8 of an inch, which is very small. That's all they need to go inside, right? For those of you in your house, if you have an infestation in the house, sometimes it sounds like your walls are humming, and you'll have a beekeeper. Again, I don't do this, but you'll have a beekeeper come in to do an extraction, and they'll remove a panel from maybe the outside of the house, or maybe they'll take some drywall down on the inside of the house, and wall to wall, ceiling to floor, as far as you can see, is nothing but bees, right? That happens sometimes because they only need a very small space. But what you're seeing here is the size of a typical swarm. It's small. She only took half of the population, right? And she's moving on to another spot. So those are kind of the things that we wanted to share. And okay, let's stop share so you guys can see me again. So,
Dr. Lee.
Yeah.
And just to add, normally the European honeybee, they would not go into a cavity if it can't hold at least 40 gallons of honey. Unlike the Africanized bees, which are, like a serious type of bees that will kill, those bees will go into anything, any small confined area, even maybe a bucket on your lawn, something small, even your meter, your water meter area on your lawn right there. They'll go into small confined space. So those are some of the things that you can also look for if you like maybe walking one day and you see a swarm of bees. Try and look and see if it's a big swarm normally European honeybee swarm normally have a large number of workers with the queen. But like the Africanized, those are much smaller nucleus, small swarms of bees. And you know, that's not the total distinguishing feature, but that can also be one of the features.
So for an African, how many are you saying for a small swarm?
It can be a small swarm, maybe 15,000, 20,000
Okay.
bees, 10,000. Normally the European honeybee, you're looking at 50,000 up to 100,000,
Okay.
big swarms.
Okay.
But that's not the only distinguishing feature,
Right.
but that can also be one of them. The Africanized bees, they're moving smaller swarms, and that is disbursement advantage they have over other bees. You will have a lot of swarms per year. One colony can give many swarms per year, while the European honeybee will give less amount of swarms per year. Yeah. And these bees, the Africanized bees, they will also invade the European honeybee colony and take over that colony.
Oh, okay.
So they are very smart. What they'll do, they will shield their queen and escort her inside a European honeybee colony. Shield her and escort her in, and they will try and kill the existing queen that was there and take over the colony. So they will also contribute to the reduction in the honeybee population.
Okay. I think Amanda had a question about what is a realistic budget to get started with a few hives?
That depends on the equipment. As Worrel was saying earlier, you could start a colony in a what are those things called? Cooler, right? Styrofoam coolers. But realistically, you're looking about $200 per hive. There are places and people that sell hive components. For instance, if you were to buy online, there's some major players. You got Man Lake, you got Dadent. Here, I'll type those down here in the comments. But these places sell online, and typically they'll ship to your house for free. Okay, and then you have local people too that sell out in Monticello. You have Tony Hogg. He's got the I think it's called Blue Crimson or Blue Moon Apiary. Blue Moon Apiary out in Monticello. Now here's the difference between the two. Man Lake's a little bit cheaper because they deal in bulk. Dayton's a little bit cheaper because they deal in bulk. But what you don't get is the experience. You go out to Blue Moon Apiary, and you've got a guy who is a University of Florida certified master beekeeper. This guy really knows his stuff. So it's really up to you. In the beekeeping world, we talk about mentors, right? Somebody who is willing to pass on the information that they have to the up and coming. And regardless of where you buy your stuff at, you want to be able to have some form of mentor. I mentor a lot. You know, every one of my customers that buy from me, now I don't sell hive parts, but I sell a select number of colonies. I don't have any more for sale this year. But everybody that purchases from me have that mentoring relationship with me. They can pick up the phone at any time and call me. You want somebody like that. Whether it's a Tony Hogg or one of the other more experienced people, seek one out. So $200 a colony, a hive. You want a bottom board? You need that. You want a deep? You want the frames and foundation that go in there. And then you want to cover. That's minimally what you need to get started. Is that going to cost you $200? No. Okay, but you need a smoker, right? If you don't want to get stuck, if you want to avoid stings, you want a smoker, you want a veil, you want a hive tool. So when I average this out, the $200 takes into account a lot of these things. And again, if you're interested in this, you know, go to my website, see my email, see my phone, text me, call me, whatever. I don't care. I'll help you get established. Okay. So I got a couple other questions over here that that I wanted to. Oh, full moon. Yeah, I see it here. Mark Lazarus has got it inside Tubelo's Cafe in Monticello. I've been out there. You know, Tony and his wife Becky are just really, really fantastic people. So, I had a question here from Betty Ashlar. She asked, if a queen leaves a hive, who takes over the hive after she leaves? Good question. When we think of queens, we think of a monarchy, right? The queen is in charge, and it's a misnomer. Queens aren't in charge. They're actually they serve at the whim of the colony. A colony is again comprised mostly out of female worker bees, and it's the colony that determines ultimately whether a queen lives or dies within the colony. If the queen is not living up to the colony's collective expectations, they will kill her in a process called supersedure. This is very normal. The only different, okay, so let's talk a little bit about baby bees. When the queen lays an egg that is destined to be a female, she fertilizes that egg. When she lays an unfertilized egg, the unfertilized egg turns into a drone or a male. The fertilized eggs, as she lays them, start out day 1 or 2, they're an egg, and then they fall over on their side, and they start to become larvae for the worker bees.
Larva. Mm-hmm.
If the colony decides that they need a new queen, the only difference between a worker bee or a queen bee is diet. Okay, so they're going to shove her with all sorts of good food. It's royal jelly. They're going to feed her royal jelly, and they draw out. And what I mean by draw, I mean they create or they make a special cell for it. If y'all remember Mr. Peanut, right? That character looks like a queen cell. It looks like a long peanut that's stuck up inside the hive. That's what who was that? Betty. That's who's going to take over that hive. And so the bees, when the queen leaves, and they know she leaves because her pheromone, she makes a special pheromone around her mouth, okay? And if they aren't in contact with that pheromone, they're going to be like, uh-oh, we need a new queen. Or if she's not living up to it and they kill her, then they say, okay, we're going to need a new queen. And so they'll go through, and they have some process that none of us really know that allows them to select a proper egg or a proper 2 to 3 day old larva, actually, and to feed it. And they're not going to just do one. They're probably going to draw out or create queen cells, which is where the queen, you know, they shove all this special food into. They'll probably draw out 5 or 6 of them on a frame. You sometimes you might have more than that. You might have 15, 20 on a frame. Worrel and I got hit, one of our apiaries, by a tornado a couple weeks ago. And when you go out to we pull the frames up because the queens got killed in a tornado, and they're just chock full of queen cells. So who takes over from the hive after she leaves? There's about a 2-week period where that colony is queenless until the new queen emerges. And once she emerges, she's a virgin. She's got to go mate. And so she comes out. She flies about 1.5 miles up. Think about it. That's where the airplanes fly, right? She's 1.5 miles up there. A whole bunch of drones chase her up in the sky. They go through this mating routine where, you know, she might mate with 10 of them or so. She fills herself up with sperm. She comes back down, and she lives out the rest of her days inside of her hive, laying eggs every day. Like I said, up to 2,000.
And interestingly, Dr. Lee, the pheromone that the queen produces, it also prevent it also prevent the other workers, the other females in the cell, from laying. So there can be a case where you have laying workers, and we see a lot of that in the air productively, where hive has been queenless for over an extended period of time, and the females the workers start to lay eggs. But the thing with these eggs, they are unfertilized because workers, their reproductive system is not as developed as the queen. Therefore, they can still lay, but their eggs are unfertilized. And then you'll see a lot of drone cells popping up inside. And another thing that you can know that laying workers have developed is that one cell will have multiple eggs. The queen will be more organized by laying one egg per cell. When you have a case where you have laying worker develops, you'll have multiple eggs. So the pheromone that the queen gives off will suppress the other females from laying and preventing a laying worker case. So after the queen dies, the pheromones stop produce. If there's no egg there for them to feed it with this highly nutritious substance called royal gel to develop a new queen, then they'll have cases of laying worker. And over a period of time, that hive will eventually dies. Full of drone and dies.
Faye, I'm sorry, I'm not going to try to do your last name. I won't do it justice. She asks, what are some good books to read on the topic? Easily to digest, a book that's easy to digest is Beekeepers for Dummies. You can get it on Amazon. It's $20 or $30. I highly recommend it. There is a subscription to a magazine, though. There's actually 2 of them that are very popular in the United States. I recommend American Bee Journal. I think that one is put out by Dayton, okay, which is a big name in the beekeeping business. I've had a subscription to it for years. I think it's very good. There's another one called Bee Culture. You can look at it. I'm just not sold on Bee Culture. I'm more familiar with American Bee Journal. Also, the American Bee Journal has a section called The Classroom in it, and it was hosted by somebody for many, many years. He retired a couple months ago, and they've got a new contributor to The Classroom. It's a guy by the name of Jamie Ellis, and Jamie Ellis is a distinguished professor of entomology and nematology over at the University of Florida, and his specialty is bees. He is the leading expert on bees in Florida. And he's highly published. He has a lot of great YouTube channels, conversations on YouTube. Jamie Ellis is his name. If you have questions, you write into it. He gives really good answers. And if you have a question, or I'm sorry, if somebody wrote into him with a question, chances are we all have that question at some point in time. So the way that he goes about answering those in that section is very informative. The benefit of the American Bee Journal then is that we have an expert over in Gainesville who is writing nationally. It's not like we have somebody from Minnesota writing, because the way we do business in Florida is different from Minnesota, right? And vice versa. So we have a local backyard expert, is what I'm trying to tell you, in the American Bee Journal. Okay, so it's, let's see here. A Year in the Life of the Beekeeper. Yes, that's a great one too. The Fat Man, I think his name is, or the Fat Beekeeper.
Fat Man, yeah.
Fat Man. He's good. His YouTube channel is. Mm-hmm. There's a lot of good stuff out. A lot of junk, but a lot of good stuff. Phyllis Ballinger asked us a question. What do you treat hives with to kill pests? Good question. So our main 2 pests that we have in the hive are the small hive beetle and the Varroa. Let's talk about the hive beetle for just a moment. In a strong colony, the hive beetles get in there. There's not a whole lot that we can do, but the colony keeps them under control to a degree. They have a very hard exterior. Generally what bees do is they'll grapple with something, they'll tangle up with it. You'll see 2 or 3 of them. They try to sting it. So the hive beetle's too hard to sting. So what happens inside the hive then is you got a bunch of bees chasing beetles around in circles. And so we have a trap. and the traps are a dime a dozen. Let's see here. The traps are placed inside of the hive so that, well, for whatever reason, I can't. Oh, here we go. They're actually placed inside of the hive, and then when the bees chase the beetles around, the beetles seek refuge inside of these traps. And there's a couple different things that we put in there. Some people use oil, some people use water. I use diatomaceous earth. The beetles go down inside of there and end up expiring. So I'm just grabbing a trap that there's so many different types, but this one here, if it loads up for me, I'll show it to you. It's very slim. It's designed to fit between the frames. Here we go. It loaded up finally. Okay, so what you're seeing here is this very small hole. This is the top of the trap. The beetles crawl down inside there, and then they fall a short distance into whatever substrate we put in there, whether, like I say, I use diatomaceous earth. People use vegetable oil mixed with a little bit of vinegar. Some people use water. I've heard people putting roach poison down in there. There's a lot of things. A more appropriate way to deal with the hive beetle is to prevent its ability to propagate. Underneath a lot of hives is ground. And so understanding the biology of small hive beetles, they'll lay the eggs inside of the hive. You know, the grub, the maggot looking thing that we talked about hatches. And once they reach the instar or the stage before they're ready to turn into a pupae or into an adult, they have to do that in the ground. And so they'll worm their ways outside of the hive. They drop down into the soil, and that's where they finish their last stage before emerging as adults. And there's a number of different ways that we can attack that. One is locate the hives in areas that have bright sunlight. Some people will tell you that you don't want your hives in full sun. I see no issue with it. The hive beetle larvae hate the sun. It's kind of like a vampire. You put the sun on them, they die, okay? Another thing, and this is what I do, is I sprinkle 7 dust underneath my hives and around the legs of the hives, and then I'll throw some leaves or something over top of the 7 dust. The worms come out, they drop down on the ground, they come into contact with the 7 dust, they're dead. Some people pour concrete underneath of their hives. These are all different ways of trying to control that. As far as the Varroa destructor is concerned, there are some insecticides that are available to place inside of the colony. Now, notice I just said insecticides. So you're going to put an insecticide in a colony of insects. Sometimes I'll say do that. Most of the times I say don't. Apagard, Apistan are 2 different types of treatment that actually go inside.
You have chipmate and you have Apivar.
And the Apistan, they go in the hives. I'm not a fan of them. I'm a huge fan of oxalic acid. And let's talk about oxalic acid for just a moment. Oxalic acid is naturally forming organic acid. And right now there are 2 ways that we treat. We vaporize it, okay? And whether we're doing that through sublimation, which is where we heat it until it turns into a smoke, or deliver it through some type of delivery system. For instance, I have a gun, for lack of better words, that heats up really, really, really hot. I mix some ethyl alcohol with oxalic acid, and I inject that into the hives, and it turns into a vapor. Mites have no defense against oxalic acid. There are dissenters out there that say oxalic acid is witchcraft. It doesn't work. It's a hoax. and I don't know. My perspective on oxalic acid, or OA, is that it works very well. As a matter of fact, I got a license from the Florida Department of Agriculture or not a license, permission, I guess you should say, to do an extended release oxalic acid treatment form here in Florida. Actually, Worrel and I will be running the experiment this summer, where the bees will come into contact with oxalic acid through a pad and a medium, in this case, glycerin. There are natural ways, or other natural forms of treatment that have good effects. One is thymol. Thymol is an oil, or a crystallized form of oil that is derived from the herb thyme, right? The stuff that we cook with. It has a good rate of killing, shall we say, a good lethal rate against the Varroa Mite as well. Some of the insecticides that I told you earlier, Worrel, which one is it that has thymol in it? Apistan?
Is Epigard.
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 And so they roll an insecticide with thymol. When I do fall treatments, I roll oxalic acid and thymol together in 95% ethyl alcohol, or Everclear, if you're familiar with that liquor. Treatment is right now, there's no approved form of treatment while honey supers are on. Which means that during the summertime months, the Varroa Mite count inside of a hive is left unchecked. It'll just keep growing and growing and growing. As soon as the honey supers come off, we start treating. And we maintain a treatment regimen all the way up to the time that the supers go back on. It's, and I'm about ready to go down a rabbit hole here with you, but you know, there's talks about natural selection and genetics that are the ability to counter this, but at what cost, nobody really knows. So we maintain treatments. Are you concerned about murder hornets? Comes somebody. No, I'm not. Not at all. Right now, the murder hornets are all the way up in the Pacific Northwest. They're nowhere near or around here. There's methods to track them. There's way that was to eradicate them before they actually get a hold. It's a long discussion. The answer is no. If something like that should actually happen, I know Worrel and I we batted around a couple different potential ways to work around it. But folk, they're not even here. They're all the way up in the Pacific Northwest, and they came down from Canada. If they were to continue to migrate, chances are they would not reach here in my lifetime. So, Lori, good to see you. All right, thank you. And then look at here, Mark Lazarus gives us something else too. The two bees in a podcast, and I'm a student. Maybe that's the wrong word. For those of you that are interested, the University of Florida has a online program called the Master Beekeepers program. It's a 6-year or 5 or 6 year program that takes a lot of the stuff that we're talking about and really gives you an in-depth dissection of some of the issues that are occurring. Sure, you're going to pay for it. It's not much, maybe $200 per course, and there's like 5 courses that are involved in this, and there's no way to do it faster than 5 or 6 years. No way, okay? But it is so informative that every time I install new bees to a new beekeeper, there's 2 things I recommend to every new beekeeper. One is University of Florida's Master Beekeeper program, and the other one is the American Bee Journal. Those are the 2 things I recommend to people. So I'm going to throw that out there for you. So Mark brought that up. Let's see if there's any. Do I have any other questions in here? Lacey, how are we doing?
You're good.
Okay, let's see. Are you familiar with Paul, the mushroom girl? Okay, so Yes, Tom Harrison. And then Jordan, I'll come back to you. Tom Harrison's talking about the mushroom guru who created a anti-mite fungi. I saw it maybe about a year ago, maybe a little less than a year ago, and I'm watching this to see what's happening. So there's an individual who has a particular type of fungus that is showing to be able to kill the mites, and so essentially he's doing is introducing this fungus into a colony. And we're talking about putting oxalic acid in a colony. We're talking about putting fungus in colonies. Maybe one of y'all are like, whoa, what are you doing? Why are you putting this in there? The bees are very hygienic. So what they do is they will go through and they take every little morsel of everything in that hive that they don't like, and it goes out the front door. So we put if we throw oxalic acid, so it goes in as a vapor, it recrystallizes in the colony. The crystallization is what kills the mites. Honeybees are like, hey, this is all good. Now we have a bunch of crystal dust. We're going to take it out. And that's exactly what they do. Same thing with the fungus, right? So we put the fungus into the hive. The honeybees are like, hey, there's fungus in here. Let's take it out. And that's what they do. So this stuff works out really well.
So, Doc.
Sir.
Doc. So the Varroa Mite, there's no silver bullet to control the Varroa Mite. So you can use an IPM strategy, integrated pest management, where you use a mechanical control, a genetical control, biological control, and a chemical control. So for the mechanical control, you can use a screen bottom board, where the mites can fall out of the hive. You can also use a sticky trap, a mesh bottom board with a sticky trap under. That's also a mechanical control. You can also use drone brood removal. So inside your brood chamber, you put these big cells, the frames with the big cells that normally would have drone cells inside. They're good for in the super for honey storage. You can move some of those empty cells, put the frames down the bottom. The queen gonna lay drone inside. And after she lay drone inside, you can remove those drone cells after they are kept. Just remove that frame. You can freeze it, you can scrape it, put it out, allow those cells to die. Because normally the Varroa Mite have a strong attraction for the drone cells because they take a longer time to develop, 24 days. Those will take to emerge. So the Varroa Mite tends to pack inside the drone cell. So you can do drone brood removal as a mechanical control. And then you have the genetic control where you can have those queens that have hygienic properties. And if you have a colony and you want to know the percentage hygienic property that colony have, you can take a brood frame, cut a square from the frame. That's a square cell with some larva. You can freeze it, pop it in the freezer overnight. And the other day you put it back inside the frame, put it inside the hive, and then you can time and see how fast the queen recognizes that those larvae are dead and remove them. If they remove it real fast, you can know that that hive have strong hygienic property. But if it take maybe 2-3 days, you know that the hygienic property for that colony is not that strong. And then from genetic, then you have biological control. So these are some biological controls that persons recommend. They use a metarrhizum. It's a fungus too, right, Doc? And we talk about that all the time. And they use the Bovera bassiana. Those are some natural fungus from the soil. So they are trying those now to use as a biological control to kill the Varroa Mite. And then the chemical is what Dr. Lee was talking about, the Epistan, the Checkmate, the Epigar, the Epivar, the Oxalic Acid. But now the Epistan, they are recommending that we don't use it anymore because the mites develop resistance to the epistant. So right now we are down to like the checkmate, the epiguard, and the epivar, and the oxalic acid. That's a good one to control the honeybee, the Varroa Mite. Yeah.
All right,
Which
I'm
one
gonna
do you
take.
prefer?
Oh,
Do you prefer using like a biological or a mechanical or?
The biological is very good, but the disadvantage with the biological is very slow. And if you have a outbreak and a serious pest problem, you probably have to jump to the chemical. So the biological is something you'd use like from before the pest population reaches the threshold. From you start to see signs, you start to introduce the biological control. But if like it's over the threshold and your hive is about to die, you probably have to use a oxalic acid, a chemical control to harass the mite population and save that colony.
I wanted to answer Jordan, and then I think that'll be about good. Lacey? Yeah?
Yeah,
All right.
sounds good.
So Jordan asks, is it okay that my bees beard outside of their hive every day? Yes, and I'll tell you why. When the bees are very particular about the temperature inside of the hive, all right? And if it's too cold inside, they all come together in a ball and they begin to vibrate, right? And that vibration generates heat inside of the hive. That's that cluster that you see if you go in on cool days where everybody's in the center. But when on the warm days, when the temperature inside the hive, and the hive is the physical structure that the colony lives in, when that temperature gets too hot, you'll have a bunch of bees beard up on the outside. And what they're doing, if you look up and you walk up there to them, you'll see that they're fanning. And they're creating a convection. They're creating an air current that goes in and out that cools down the hive. So most people see bearding in the evening. That's because they're trying to cool that hive down to the proper temperature for life to be sustained inside there. What is it, Worrel, 93 degrees or 95?
About 95, yeah.
95 degrees. It's got to stay that temperature. So, you know, it's hot out and the sun's been beating on them and all the other stuff. Yeah, they got to cool it off. So they use that. You know, they bring in copious amounts of water up inside the hive. You know, to help cool it. They also, when they're storing their honey, that honey, the nectar that they're bringing in is so liquid too that they have to dehydrate it down into that thick stuff that we like. And so part of that bearding process may be, as they're circulating air in there, is to reduce the humidity. It's hard to say, but it's very complex. But to see beards, it's perfectly normal. It's perfectly normal. Okay.
Yeah. And Doc, as you mentioned, that boiling and vibrating and increased temperature, the bees the bees that are in Asia, the strains that in Asia, the honeybee, that evolved and get accustomed to the murder hornets. That's one of their control approach. So those bees, they will stay in their colony. The murder hornet will come and there and fly around. They will stay still. And then when the murder hornet get very close, they will just swarm that murder hornet, form a ball, vibrate, and fright. So they will increase the temperature so much, over 100 degrees Fahrenheit, and kill that murder hornet, and then they will clean the pheromone. So that pheromone won't call other murder hornet, won't attract other murder hornet. Unlike our bees our European honeybee now, each one of them will try individually to attack that murder hornet. And then the murder hornet will just kill them. And while killing them, give her pheromone and attract other murder hornet. So they in no time they'll just more and more just come and just kill all our bees from the colony. So two different approach. So and that's from some form of evolution, right? They coexist together. So those bees over there, they know how to, they have developed strategy how to protect themselves against these pests. Yeah.
All right. We good? Any other?
Anything else? I don't see anything. I don't think we missed anybody.
Well, my normal closing is thank you, Lacey, for having me on here, and to
Absolutely.
all of the participants. I appreciate that you took the time out of your day to listen to me, so I greatly appreciate that. And that was my cat running across the room. If you heard that bell, I apologize. Worrel, I greatly appreciate you for giving up your time to come in here. And if you guys have any suggestions that you'd want to hear from me, whether it's on the bee commentary or going back to the crime stuff or something that you want to know, Lacey, I'm more than happy to come back at any given time, and we'll keep this up.
Yes, absolutely. And we thank you so much from the museum on behalf of myself and the museum. We love you, and we're looking forward to working with you in the future. We are continuing the series next week with another crime lecture, Cocktails and Crime. Charlotte Perdue from FSU's Panama City chapter will be joining us talking about blood spatter analysis. So if you're interested in that, please join us next week. And then the following week, we've got someone talking about herpetology from also FSU. So please keep joining us every week. And again, we are so excited to be continuing this series. It's great for home entertainment while this whole pandemic's going on. So something different than watching Netflix every night. So.
Right.
Thank
All righty
you again,
then.
Worrel and Lee.
All right. Take care, y'all.
Thank you for having
All right.
me. Thank you.
Have a good evening.
Okay. Bye.